So, example, suppose a rock falls down from the top of a cliff. What is the change in velocity of the rock after it has fallen for 1.5 seconds and it says a sign down is negative? You know what? I usually won't tell you that. Ty, let's just decide, unless the question specifically says different, down is negative, up is positive. That makes sense to me. What's this question asking me to find? Okay, this is a bit strange. It's asking me to find this thing. Now, either you have your purple formula sheet out or you're looking at the front of the handout. I got several equations with change in velocity, and I'm not sure which one I'm going to go with. Allison, you know what's going to help me figure out which one to go with? The data that they give me. So I look for numbers. I see that there. Allison, my joy, can you read to me what I just underlined here? 1.5 what? What is that? Seconds time. So I'm going to write down now there's one more thing, and this we're all going to do. Can you all underline the word false? Okay. And then draw an arrow pointing to the word false. If I tell you something is in free fall, we now know the acceleration. They don't need to tell me. Who remembers from last day? What's the acceleration? Negative 9.8. My physics 11s and 12 students all have that one memorized because they get sick of looking it up. Although I give it to them on the formula sheet, they just, to me, memorizing should be because you're lazy and don't want to look it up, as opposed to because you have to. So, negative 9.8 meters per second squared. That's the acceleration. So please tell me, on the formula sheet, is there a change in velocity equation that has an A and a T next to it? Okay, this is how, because there's 3 delta V equations, right, Ty, on the formula sheet? Which one? Hey, how about the one that's got the A and the T? Which I think it says it this way. Although I don't know if it has the vector symbols on it, but I'm a nerd. I have to put them on there because it's correct. Is that right? Is that right? Okay. Now it's plug and chug. It's going to be negative 9.8 times 1.5. Can I do this in my head? Sure, I can. It's going to be negative 9.8 plus negative 4.9. It's going to be 13.7. Negative 13.7? No, that's wrong. Yeah, that's right. Negative 13.7? 14.7? I forgot to carry the 1. Units. It's a velocity. It's a change in, but it's a velocity. What are the units? So on your test, I will take a half mark off if the units are missing or wrong. What should you do before you hand the test in? What would be a smart thing to do just before you hand the test in? Check all the written questions. Make sure, A, you have units. Make sure they're the right units. What if I forget? What if you forget which units go with what? If you're a good test writer, where might you be able to find some hints as to what units go with what? In the questions, in the multiple choice sections in particular? Right, you guys have figured that out, that often you can find an answer to the written somewhere on the multiple choice, especially like in French. I could often find a word and how to spell it somewhere on the multiple choice. I remember doing that trick. Right, I hope that wasn't a revelation to some of you. Okay. What's the change in velocity of a brick that falls for 3.5 seconds? You know what? This is the same question. I'm not even going to defic. I'm going to go straight to plug and chug. Because they told me falls, which means gravity acceleration is negative 9.8 times 3.5 negative 9.8 times 3.5. Can I do that one in my head? Ooh, that's a bit yuck here. 9.8 times 2 is 19.6, 29.6, 29.4, 33.4, 34 point, negative 34.3? Am I right? I carried the 1 this time. You guys should be a little impressed. I'm doing decimal math in my head. And it's meters per second. Now, here's what this is saying. If you started out at 0, then after falling for 3.5 seconds, Conlon, you'd be at negative 34.3 meters per second. If you started out at negative 1 meter per second, then you'd be at negative 35.3 meters. If you started out at negative 10 meters per second, after 3.5 seconds, you'd be at negative 44.3 seconds. It's just saying that's your change in. Your velocity would have gone in the negative direction, 34.3 meters per second in 3.5 seconds. I like this next one, I like this next one, I like this next one. What's this question asking me to find? Time. How long? All right. Now we go look for physicsy words and numbers. I see a 14. See it? What are the units next to the 14? So what is that 14? Now, it's a velocity, and then I'm going to say, which one? Is this the initial or the final velocity, that 14? And all that, Matt, I can't teach you. All I can say, read the question. That 14, are we initial or final? What do you think? Sorry, I caught you zoning out. You with me here? This 14 meters per second, is that my initial velocity or my final velocity? Yep. How do you know? Because they gave me another one, and that clearly is later. Okay. What's that 6? Brooke, what are the units next to the 6, kiddo? M is meters. Right, I've circled it. Meters per second. So here's the question, folks. Meters per second. It's a velocity. Which one? V final. This is not enough. There has to be something else. I know one more thing. What's the acceleration? Not positive 9.8. Negative, because when you throw something up, it's slowing down. Negative. Okay? Soon as it leaves your hand, Courtney, even if it's on your way up, it's still in free fall. As soon as it leaves your hand, whenever you throw something, its acceleration is negative 9.8 meters per second squared down. Please tell me there's an equation that has t by itself. Yeah? What's the equation that has t by itself? I don't think it's v divided by... sorry, say that again? Okay. Here's what Taylor said. Don't write this down. Well, okay, we'll write this down. Which change in velocity am I going to use? How do you know? Yes, I told you to draw arrows, but how do you know from the data? Look at what they gave me. Okay? So it's going to be v final minus v initial over the acceleration, and I'll be fussy and put vectors there. By the way, the final velocity, that's 6. See it? Is it traveling up or down? Read the question. Up? What if it was traveling down? How would I show that? Just put a negative in front of it. It'll still work. Oh, and that 14 up, also, it's a positive. The formula puts a negative there because change in anything is final minus initial. So now we plug in Chug. 6 take away 14 divided by negative 9.8. Do that one in your head, Mr. Dueck. Dividing by negative 9.8 is yucky. Yep. Can anybody see what I've done wrong here on my calculator? Because I have. This will give me the wrong answer, guaranteed. How many numbers are on the top of this fraction? If I'm going to use a scientific calculator and type this in one fell swoop, I need to put brackets, or I need to hit equals. I can either go like this, delete, 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 equals, and then divided by negative 9.8, or I can go bracket 6 minus 14 divided by negative 9.8. But what I can't do is go 6 take away 14 divided by negative 9.8. That's the wrong answer there. The correct answer is 0.8163. You know what? I'm going to go 0.82. What was this question asking us to find? Time? Units. Seconds. Couple more, we're done. And then we practice this. What's this next one asking me to find? Velocity. How do I know it's final and not initial? Okay, they gave me the initial velocity. All right, they want me to find that. Guys good? A little focus. What have they told me here? What's that 8? What's the initial velocity? 8 is wrong. Why is 8 wrong? Everybody, right now, underline the word downwards. And I will give you one like this on your test as well, Andrea, where I'll put a downwards. Direction matters. The initial velocity is negative 8 meters per second. What's that 1.5? Time? This is not enough. There must be something else that I know. If I throw something, if it's in the air, if we are in free fall, I always know this. What's my acceleration when I'm in free fall? Negative 9.8. Please tell me I have an equation with a VF by itself. I hope. Well, it looks like I have this one here. VF equals VI plus delta V. Wait a minute, Mr. Dueck. I don't see a delta V anywhere up here. Or do I? Can I do this? How else can I write this? What can I replace that delta V with? Well, I got two options. One would be to go V final minus V initial. The problem is, what am I being asked to find? V final. Putting a V final over here when I don't know it would be silly. What's the other way that I can write delta V according to my formula sheet? And again, let me assure you, Dylan, I would never teach it this way, but this is how they want you to do it on the provincial. Oh, this is fingernails on the blackboard to me. Is that right? Double check. Do I know VI? Yep. Do I know A? Yep. Do I know T? Yep. Plug and chug. Negative 8 plus negative 9.8 times 1.5, which is what? By the way, if you stood on a cliff and you threw a rock downwards off the top of the cliff, after 1.5 seconds, what direction would the rock still be traveling? Downwards. Am I expecting a negative or a positive answer here for my V final? Should be a negative. In physics, one of the things I like about physics is there are, Ty, built-in error checks. I know I'm heading down. I better get a negative answer. If I don't, I've either made a mistake in my data or I've made a mistake in my calculator. What do you get? Get this one in your head, Mr. Dueck. Okay. Negative 9.8 times 1.5 is going to be negative 9.8 plus 4.9 is negative 13.9 is negative 14.4 plus 8, negative 22.4? 24.4? Negative 24.4? Oh, I'm way off! Dueck! Don't trust them. Really, Cal? Wow! Negative 22.7 what? Meters per second. Last one, and I'm going to give you lots of this to practice. Terminal velocity for an average skydiver is negative 54 meters per second. It depends, by the way, on your surface area, how big you are, but average, it's around there. When Mr. Dueck jumped out of an airplane, I mentioned that I jumped out of an airplane. When Mr. Dueck jumped out of an airplane, how long did it take him to reach terminal velocity? You guys watched the video. The video was in slow motion. In real life, how long was I in free fall for before I hit terminal velocity? What's this question asking me to find? No. Cool. What else do I know? What's that negative 54? It's a velocity. Initial or final? I heard someone say initial, I heard someone say final. V final? So then, what the heck is that? And I'm going to give you a hint. Put your pencils down. You saw the video. What's my initial velocity right now?
0.
Starting from rest, 0. I jumped. Ah! What was my acceleration? Is there an equation that has the t by itself? I hope. I think that one says t equals change in velocity over acceleration. Is that right? I hate that equation. I would never phrase it that way. Which change in velocity do they want me to put in? The one that says at? Well, no, because that's got a t in it, and I'm trying to find a t. Wouldn't make sense. What's the other change in velocity? How long was I in free fall for before we pulled the ripcord? Actually, I fell at terminal velocity for a few seconds as well. So how long did it take me before I stopped speeding up, before I hit terminal velocity? Not that long. I guess I didn't really need to go minus 0 because that's not going to change the answer. But just to show you, that's how you could type it into your calculator. 5.5 seconds. Nope, not very long. Okay, terminal velocity, you hit it pretty quick. What's your homework? Can y'all look up for a second? Last day, I gave you this, so you're going to get some time to work on this here. This was calculating acceleration, lots of the math stuff, and then the answers, one sheet. You should get that one done in class. I'll help you if you get stuck. That one, as far as I'm concerned, I'd love you to hand in before class is over. That's from last day. Then, today, I've given you practice with, I called this gravity. This is lots of free fall questions. So remember, for gravity, the acceleration due to gravity is negative 9.8. Thank you. If you write small, reasonably small, you can do all your work on here. I did put the answers next to each question, which means if you just write an answer, I'm giving you 0. I need to see at least one line of work. I would use the DFIC approach until I got very, very good. So number 1 says, what's the velocity of a freely falling object after each of these times? Assume VI is 0. You know what? If VI is 0 and they're asking me to find a velocity, which velocity must they be asking me to find? V final. Oh, you're in free fall. What's your acceleration? Negative 9.8. So I'm giving you different times. You should find that question, you're using the same equation over and over. It gets kind of repetitive. Number 2, how long does it take a freely falling object to reach the final velocities? So here, I'm asking you to find time, how long, and I'm giving you the V finals. It's sort of a reverse of question 1. Number 3, what's the change in velocity of a hailstone that falls for 4 seconds? Change in any, you know what, you can find that on your sheet as well. Ball is thrown up in the air. How much time does it... Oh, you know what? 4A is asking you to find time. Which is the one I want to talk about, Mr. Dueck? You know what? I'll let you work through all of these. I tacked this on at the end of last year. You may recall a couple of years ago, Felix Baumgartner did a space jump from outer space. So I went to the website and I yoinked the numbers. So number 9, part A, the speed of sound is 333 meters per second. How long did it take him to break the speed of sound? He did actually break the speed of sound when he was in free fall. After 50 seconds of free fall, he hit his maximum velocity. How fast was his maximum velocity? And then see if you can convert that to kilometers per hour. Has something to do with a 3.6. And then there's a little thought question. I'm going to give you all about half an hour to work on both of these. See if you can get them both done in class. Otherwise, this sheet here will be due next class, and I will take questions as well. So the 9.2, this one, try and get it done in class. And then this one, try and get done in class. Oh, sorry, where is it? This one, try and get done in class. This one finished for next class, and in about half an hour, we're going to start the next lesson.